They have the ability to divide for indefinite periods, potential to differentiate different types of cells. James Thomson in 1998, he was the first person who isolated cells from the inner cell mass of the early embryo and developed the first human embryonic stem cell line. So you can say the father of stem cell studies is James Thomson, and it started just in 1998. What are the different sources of stem cells? Right from the embryonic phase, to the fetal, to the infant, and to the adult phase. At present, we are concerned about the last one, is the adult phase, the somatic cells. It can be mesenchymal or hematopoietic. These are maximum being researched. Mesenchymal stem cells originating from the bone marrow, or the hematopoietic cells again coming from the bone marrow or from the parathyroid gland. These are the maximum researched cells in the present era. But we must know the different types of cells, because a lot of issues are there in the stem cell research, which I will tell you later, what are the problems. If we go overboard, the ultimate stem cell researches will be just like a human person is trying to be God, which nobody wants. And its other legal repercussions can be very, very dangerous. So we have got totipotent cells, pluripotent cells, and the multipotent cells. In a nutshell, you must understand that totipotent cells, they can produce a complete human being. Pluripotent cells, they can form an organ. And the multipotent cells, they can produce a tissue. This is the main gross difference between the three types of cells. Germ cells, zygote, is totipotent, which can form a human being. Pluripotent cells. Now the research is there that from the embryonic tissue, you can produce, you can form a liver, you can form a heart, you can form a kidney. Those are the pluripotent cells. And the research where I am concerned, and the most of the people are concerned, is the multipotent cells, where we can form a tissue. We can form a bone at the desired area, we can form a cartilage, we can form a collagen, we can form a tendon, we can form any type of tissue can be formed. Those are the multipotent cells coming from mesenchymal stem cells. The potency, as far as the regeneration power is concerned, it keeps decreasing from totipotent, pluripotent to multipotent cells, because the maximum, the highest quality life is in the embryo, then it comes into the fetus, and then to the adults. I'm trying to simplify the things for you people. Now we, at present, we are concerned about the adult stem cells. So they are hematopoietic, mesenchymal, or endodermal cells. So hematopoietic, as we know, RBCs, platelets, they keep changing with the passage of time. Mesenchymal stem cells, they replace bone, tendon, muscle, cartilage when they are injured. Because as far as the bone is concerned, you must know this is a reparting process. Bone is not a structure which has been formed and that lies there for all the time. Osteoclastic activity keeps on resolving the bone, and osteoblastic activity keeps on forming new. So bone anywhere in your body is changing its cells. The last is the endodermal stem cell. Does it replace the GAT cells? GAT lining is being changed time and again. Now, adult mesenchymal stem cells, they come from the bone marrow. This is the main source. Adipose tissue. From the abdominal fat, after liposuction, they are collecting it and separating the mesenchymal stem cells. From the blood and from the joint tissue also, from the synovial also. But the maximum source is from bone marrow stem cells. Because they say this is the highest quality mesenchymal stem cells available in the adults, which can be used to replicate things. So bone marrow derived cells, they are taken by a needle through the bone marrow aspirate, and adipose tissue divides from obtained by liposuction. For orthopedic applications, fat derived cells, they underperform quite a lot. They are not of very high quality cells. The main benefits of bone marrow derived stem cells are orthodox. They are taken from the same person. Bone marrow is taken, stem cells are separated, and then again injected into the same person. So as far as the problems of taking tissue from one person to other person to inject into, there is no such problem. Unlimited supply. You can take as much as bone marrow from somebody's areas. They do not express HLA2 antigens. So this is important. This is expressing the HLA2 antigens means causing a reaction. They don't express this. So it can be used from one person to other person as well. Stem cells, bone marrow taken from one person, separate the stem cells, and you can inject into somebody else's without expressing any antigens. But the problem will come that genetically disposed diseases may be transmitted to another person. So still it is in search, research is going on. And they have strong evidence of in vitro and in vivo differentiation. Even in the laboratory, it can be recreated. You take a sample, grow it in the laboratory, make it multifold, and then inject it. So allograft can be used, autograft can be used, but again the problem is possible to transfer the genetic diseases through the stem cells transfer. So for the next 20-30 years, still that problem is not solved. Only we are concentrating on the autologous cells only. We do not use, and we don't intend to use, somebody A's cells into the B. Now how? The bone marrow can be taken. So under anesthesia, patient is put thrown, and from the posterior iliac crust, because the posterior iliac area is the thickest flat bone, cancellous bone, where we put a multi-bore needle and aspirate the bone marrow. The putting multi-bore needle is very important because they say from a one particular hole, you should not take out more than 3 to 5 ml of bone marrow. That will cause problem at that area. So that's why multi-bore needle is put. So from the different areas is being aspirated. And after that, variant centrifugation is done, and we get mesenchymal stem cells in the seed. Stem cell separators machines are available. That costs around, in 2015 it was costing around 13 lakh. And one disposable kit where we aspirate the bone marrow and put it in the machine. That one kit costed around 70,000 rupees. Similarly, plated PRP separators are also available. Kit is this machine is the same, but the kit is different. There are other ways to separate the stem cells also. So in orthopedics, stem cells have been used in different conditions, like in cortical bone defects and non-juveniles, avascular necrosis. Because avascular necrosis, if not treated properly and in time, it will lead on to joint replacement. So if we can avoid the joint replacement work in the stem cells and rectify the problem, that will be a big venture for the human race. Cartilage repair. This is the area where the maximum research is going on, because as the age advances, osteoarthritis invariably ensues. And if we can replace the cartilage, a multi-million and billion economy will be saved in the form of avoiding joint replacements. Because so far, there is no medication, nothing is available which can replace the cartilage. In joint, we have got hyaline cartilage. If when repair occurs, it's only the fibrocartilage which is formed, hyaline cartilage is never ever formed. If this is successful, this is the biggest achievement for the human race. Then in the ligaments and tendon injuries, meniscal repair, because even meniscal injuries, they are avascular structures. Whenever meniscal injury occurs in a sports person, invariably the person lands into surgery where the meniscectomy has to be done. Menisci, they do not degenerate. They do not heal. Only the partial tears heal. Then a spinal cord injury. Now again, this will be a revolution. Because so far as the human science knows, the neurons can grow. But the neuronal cells, they do not grow. Once a neuron is dead, it is dead. If an axon is cut, the tail of the neuron, that can grow. But the neurons, they do not grow. The maximum research is still going on in the spinal injury cases, where the neurons are dead. They're trying to regenerate the neurons, and some success is there. Muscular dystrophies. So far, there is no treatment available for muscular dystrophies. If stem cells can regenerate the muscles, the human race will come from no treatment to absolute correctability. Now, the goal is to harness the natural healing potential of the stem cells. There are no reports of adverse effects with autologous mesenchymal stem cells because they are autologous. You must be knowing that blood transfusions are done. Sometimes reaction occurs, but that blood transfer is from one person to another person. Here, it is autologous. You have taken the bone marrow of the same person, separated the stem cell, and injected it to the same person. So there is no problem at all. And these stem cells are available throughout life. But the knowledge of origins and the phenotypic characteristics of progenitors and the controlling factors is there. Now, what signal is to be given at the injected site? What combination, with what combination is to be there? So that the stem cells, they get activated at that area and they form the similar type of tissue that is still a gray. We do not know absolutely, and we're still working on that. So we can either take the stem cells and culture them in the laboratory and make it multifold, or we can directly separate the stem cells and inject at the desired area along with hyaluronic acid. So hyaluronic acid is one combination with which stem cells can be used. The following the injection, Stem cells would be distributed throughout the joint space and would interact with the available receptor cells and surfaces, and several synovium when we inject into a joint. Synovium is the first structure which comes into contact and which stimulates the further action of the stem cells. The second factor for orthobiologics is the platelet-rich plasma. So we have totipotent, pluripotent, and multipotent stem cells. Next, one step down is the platelet-rich plasma. This is slightly shorter stem cell, but still it works fantastic. And my work for the last 10 years is on this platelet-rich plasma. It is that the stem cells are the seeds in the lawn. PRP is the fertilizer that helps the lawn to grow, and of its own too they have the growth. The PRP, platelet-rich plasma, through its growth factors, they provide cell signals and the nourishment to help the stem cells flourish and develop into new tissues. Again, the function is the same. PRP, whereso we inject it, tries to make the similar tissue. If injected into a bone, it will try to form a bone. If we inject it into a joint, it will try to form a cartilage. If we inject it into the ligaments or tendons, it will try to form a collagen of ligament tendons. The maximum use of this PRP has been in sports conditions like tennis elbow, plantar fasciitis, rotator cuff injuries. It has been being used for the last many years. So it not only triggers the stem cell development, but can also help stem cells regenerate on their own inside the human body. Wheresoever we inject the PRP, it tries to attract the mesenchymal stem cells from the surroundings. Because mesenchymal stem cells are available in the cancerous bone. If we inject it to a knee joint, it will try to attract the mesenchymal stem cells from the condyles of the tibia as well as the femur. So this is the characteristics of the platelet-rich plasma. So we call it by different names: platelet-rich PRP therapy, platelet concentrate, growth factor-rich plasma, etc. Now, platelets have two types of granules, alpha and dense or delta granules. The growth factors are present on the alpha granules of the platelets. And PRP means we have concentrated the plasma where the platelet concentration is 5 to 7 times higher than the normal. This is around 1.5 to 2 million platelets per cubic centimeter. It's 5 to 7 times higher. That is the concentration which we call as the platelet-rich plasma. It also helps in the angiogenesis, that is the new vascular adhesion, because wheresoever the repair is required, new vascular adhesion is the most important factor. Cell proliferation and the differentiation into collagen production. They also have enzyme vitreonectin, PRP. They contain the vitreonectin, which helps in the osteointegration and osteoconduction. That's why this is very, very helpful for the bone formation in non-humans. Around 30 growth factors have been enumerated, but around 6 or 7 are the more important, which have been studied quite extensively, and they are of good use for the clinical application. Now, we have got the platelet-rich plasma. Now, it has to be activated before being used. So, activation is in two parts. One is degranulation. We have to separate the alpha granules from the platelets, and then its activation has to be started. One factor is we combine with calcium chloride with thrombin. Now, this is a very good method, but a lot of ethical issues are there. Because the thrombin which is available, it is a bovine thrombin taken from animals. And in India, we are Gau Mata hai. If somebody, I would say, a staunch Brahmin from south, he comes to know that he has been injected with the bovine thrombin, he will sue you in the court. या थोड़ा सा बात करें. So lot of ethical issues are there. So the people have stopped choosing to withdraw as far as India is concerned. Other is the freeze time. You freeze it and then you rapidly thaw it. But that only separates the degranulate of proteins. It doesn't activate the proteins. The third method is direct exposure to the collagen. This is the best method because wheresoever there is an injury, collagen is always there. And I am using this third thing for the activation of the proteins. Suppose there is osteoarthritis, there is an injury to the meniscus, ACL or so. So where the injury is there, collagen is already there. So inject it over there and it gets activated. So PRP can be injected directly into the injured tissue, which becomes activated on contact with the collagen. Collagen is one of the most potent activators